In this little film, what we're going to be doing today is thinking about the GDP deflator. The whole point of the GDP deflator is to calculate real GDP after one has defined whatever a base year is. So, to give you kind of a broad sense of where this is in terms of our studies about measurement in the economy, GDP is the quantity measurement and inflation is the price measurement. And what we're trying to do here is link the two together, because if we don't account for price changes in an economy, then, which means we'll be calculating nominal GDP, then we're not taking out the distortive effects of prices. We might be making bad judgments about how productive the gains in the economy actually were. So the GDP deflator allows for us to do this in really easy fashion. So what I've done is I've set up some hypothetical data here for 2 years. I've got nominal GDP in both of those years, and then I've got a CPI measurement, the Consumer Price Index, which is the U.S. government's inflation measure. I've got those numbers for the same years. Now the CPI always works where if you see that a year has a measurement of 100, you can assume that that's the base year. So we can assume here that year 1 is the base year, and we can then compare years around that using the GDP deflator and taking these values, these nominal GDP values, and translating them into real GDP, and then comparing them to this to see if economic growth occurred. So at the end of this exercise that we're going to do here, what we want to be able to determine is whether or not any economic growth occurred. That's really where we're going here. So let's take a look at how we can use the GDP deflator with these data. So the GDP deflator at first blush looks kind of complicated because you got a little bit of a fraction here, and you just have to understand how to manipulate the values that we're giving in order to calculate this number that we want to calculate. So we've got the nominal GDP in the numerator, and then we'll call this for year X, and then the CPI for year X is going to be part of the denominator, and then we're going to divide that by 100. So make sure we understand what we're doing here. In the denominator, we're looking at the relative price change. And we're going to take that relative price change and we're going to divide into that numerator value in order to shrink the prices that were used to calculate that nominal GDP value. And once we've shrunk those, then we're paying more close attention to the quantity of goods that were produced, rather than looking at the price times the quantity and getting a distorted sense of what productivity change was. So, given the data that we've got with regards to this economy, we can substitute 1.1 trillion in for the nominal GDP, and then for the CPI value, the CPI in year 2, which is the year that we want to deflate, in essence we want to translate into that year 1 price value. So the CPI for year 2 is 104, and we're going to divide that by the base value. And when we do this, we get an approximate real GDP for year 2 of 1.06 trillion. And I would go ahead and make sure that you can get that value. Get your calculator out and divide 1.1 trillion by 1.04. You'll come up with a value of approximately 1.06 trillion. And just to take a step back, what we've done is we've shrunk this nominal GDP value, And by shrinking it, we have translated it, we've taken those prices from year 2 and translated them into year 1 prices so that we can make a more accurate conclusion about what happened to economic growth. GDP is a quantity measure. We don't want prices to distort that. So we've shrunk those prices from year 2 into year 1 values, and now we're comparing more closely the quantities of those goods that were produced. Now the last thing we've got to do, we've got to translate this into economic growth. So the real GDP for year 2, 1.06 trillion, is bigger than the real GDP value for year 1, so economic growth occurred. And we have a much more accurate picture about the productive capability of this economy in year 2 compared to year 1 because we have taken out any sort of price distortion that might have caused us to make an incorrect conclusion. So our conclusion's more accurate, and it's good here that this economy grew. So the last thing that we want to kind of think about is that we can take we can decompose the nominal changes that occur in economies into 2 different parts. There's the part that's due to inflation, and then there's the part that's due to real changes that are occurring. And when we add these 2 changes up, we end up with the nominal change. So if we look at the data that we just used, the inflation was 4% across those 2 years. The CPI value of 104 compared to a base of 100 gives us a 4% inflation change, and the real change was about 6%, and the nominal change, a $1.1 trillion nominal GDP compared to a $1 trillion nominal GDP, is a change of 10%, right? 4% inflation change and 6% real change adds up to a 10% nominal change. So we can always decompose nominal changes into the inflation change plus the real change to see what the total nominal change was. And this is something that we'll do throughout the course of macroeconomics. We want to do this for real changes to GDP. We want to think about interest rates in the same way. We have to tease out what inflation was doing in order to figure out what the real value of economic change was.